Hello, class. We are going to cover 4.5 today, exponential and log equations. So hopefully you mastered those properties of logs because we are going to use them here when we are solving for logarithms. We are covering both log equations and exponential equations. Okay, so 4.5. I think I want that size. Okay, exponential and log equations. Okay, we're going to start off with exponential equations. And these two go hand in hand when we're solving because they are inverses of each other, just like square root and x squared are inverses of each other. And we use them to solve for those types of equations. If you're given an x squared, we can use the square root to solve for x. If you're given a square root, we square both sides, okay? So same thing here, because exponential and logs are inverses of each other, we use them to undo the other operation, okay? So exponents undo logs, logs undo exponentials. Okay, so with exponential equations, let's start with something obvious first. So before, we had things like this where you had to determine what x is. And this is obvious because we're pretty familiar with powers of 2. And so we can see here that x would have to be equal to 3. Okay, so this one is obvious. Okay, so now what's going to happen is we're going to have exponential equations that we need to solve that are not so obvious. So even something that looks simple like this, 2 to the x equals 7, this one here is not so obvious. Okay, we see here that if we try x equals 2, that's too small. And if we try x equals 3, that's too big, right? Because if we plug in 2, we get 4. If we plug in 3, we get 8. Okay, so we want 7. So that must mean that our answer must be somewhere between 2 and 3. Okay, so here we will be having decimal answers. And again, it's hard to figure out what the decimal answer would be unless we have some other methods. Okay, so the method that we are going to be using is logs. Okay. All right, so let's go ahead and take that same problem, 2 to the x equals 7. Okay, so what we want to do here is we're going to take the log of both sides. So let me go ahead and write that problem down here. Okay, so we will take the log of both sides. And it doesn't matter which log you use on your calculator. Usually we have log base 10 or ln natural log log base e. Okay, so it doesn't matter which one you use. You'll still get the same answer at the end. All right, so take the log of both sides. So I'm going to do log of 2 to the x, and I will do log of 7. Okay. Here, I'll put a little note here. So you can use log or ln. It doesn't matter. Okay, and then we're going to use the property of logs that allows me to bring that exponent down to the front. Okay, so bring exponent down. Okay, so that allows me to bring it down to the front, which is great because then now this just becomes a regular solving equation. So here we have multiplication with x. So in order to solve for x, then I have to do the opposite operation or the inverse operation. So if that's the multiplication, then I will need to divide both sides by log 2. Okay, so divide by log 2. Okay, so they cancel out. And what you do to one side, you have to do the other. So here I end up with x equals, if I punch that into my calculator, log 7 divided by log 2, I get roughly 2.807. Okay, so I like 3 decimal places on the test, on my test. Usually I give a paper and pencil test, but last semester when we went online in March, it was kind of a difficult thing for students to print and to scan and to write on the test on their screen. So it was just a big mess. So you guys are going to be using Cengage WebAssign to take your test that's coming up. So pay attention to see how they want you to write the answer. If they want 1 decimal place, 3 decimal places, etc. Okay, so that is pretty much how you solve logs here. This one's kind of your basic equation. You always try to get the exponential by itself. Okay, so, and once you do, then you can take the log of both sides just to bring that variable down out of the exponent position. Okay, so let's take a look at another one. Solve 3x equals 5 and round to 3 decimal places. Okay, I'm going to bring this here. So again, the exponential is by itself, so I can go ahead and take the log of both sides. And then just to show you, I'm just going to use ln this time to show that it doesn't really matter which log you use. Okay, so I'm going to use ln. So I'm going to take the natural log of both sides. If you're at home and you want to check to see if you use log base 10 to solve this, you can do that. You can use your log button and then see if your answer is the same as mine. Okay, so here, taking the log of both sides allows me to bring the x down to the front. So I will. And then here, I can solve for x. So I can divide both sides by ln 3. Okay, so x equals 1.465. And we really should say approximately equal. All right, so let's take a look at another one. Let's go ahead and solve 3 to the 2x plus 5 equals 17. Okay, and again, let's round to 3 decimals. Okay, so here, 3 to the 2x plus 5 equals 17. My exponential is by itself, so I can go ahead and take the log of both sides. Three to the 2x plus 5, and the natural log of 17. When I'm working these out, I don't really have a preference between the logs. There is less writing for ln than there is for log. Okay, so taking the log of both sides allows me to bring that exponent down. Now you have a full expression there, so make sure you bring down the full expression 2x plus 5 and use parentheses. Okay, use parentheses. It will help keep things organized. It'll help you to see what operations you need to do next. Okay. So here I'm going to go ahead and I have this multiplication by ln3, so I'm going to divide by ln3 on both sides. And so I'm going to have that. However, I'm not going to punch ln17 over ln3 into the calculator just yet. If you do that, then you risk not having the most precise answer at the end. So I will leave it as ln17 over ln3, which is some long decimal answer. Okay. And so now I just solve for x as usual. I will need to subtract 5 on both sides and then divide by 2 on both sides. So let's go ahead and do that. Subtract 5. And that will cancel out, leaving me with 2x equals, again, I will leave this as ln17 over ln3. Subtract 5. I'll eventually do that all on a calculator. And then solving for x, we need to divide both sides by 2. Okay, so x equals, once you punch this all into your calculator, since you're dividing the entire top by 2, you might want to, when you punch this into your calculator, keep it all in parentheses if you're doing it all on one line. If you're doing, natural log 17 divided by natural log 3, and you keep doing equals, and then you do minus 5 equals, and then divide by 2 equals, that's fine too. All right, so you should get here negative 1.211. Okay. Okay, I'm going to have you try this next one. Okay, go ahead and see if you can solve this one. Solve 3 times 5 to the x plus 4 equals 11. Okay, so when you look at this one, the exponential is not by itself yet. So you will have to get the 5 to the x by itself first. So make sure you subtract 4 on both sides and divide by 3. Then you can do the log. Okay, so go ahead and press pause and work this out, and then come back to see if you have the same answer as I do. So here we need to get the exponential by itself, so I need to subtract 4 on both sides. Okay, and I need to also divide by 3 on both sides. And once you have the exponential by itself, now you can go ahead and take the log of both sides. Okay, again, it doesn't matter which log you do. If you do log or ln, that's fine. So ln of 5 to the x, ln of 7 over 3, and that allows me to bring the x exponent down to the front. And now I can solve for x by dividing both sides by natural log of 5. Okay, and your final answer, you should have gotten x is approximately equal to 0.526. Okay. All right. Now, this next one, if you notice so far, these examples have only one variable uh, in the exponent. Okay. So let's take a look at this one. Let's go ahead and solve. 3 to the 2x minus 1 equals 2 to the x plus 1. So now we have variables on both sides of the equation. So this is going to take a little bit more work. So the important thing here is to try to keep everything nice and organized. Okay, so both exponentials are by themselves. So we can go ahead and take the log of both sides. Okay, and that will allow me to bring the exponents down, both of them. Again, use parentheses to keep everything organized, especially with a problem like this one. Okay, so we have this different ways to go about doing it from this point forward, but I would say the easiest one for students to understand is to distribute the natural logs on both sides. Okay, so here, this one would be ln 3 times 2x and ln 3 times negative 1. Okay, and then on the right-hand side, we have ln 2 times x. I'm going to keep the x out in front so we don't think it's part of the log. Okay. All right, so now here, what you want to do is gather all the x terms on one side and gather all of the non-x terms on the other side. So I am going to, I'll subtract this one to bring it over here with this one. Okay, so here, this ln 3 times 2x, probably a better way to write that. I'm going to go ahead and erase it. I'm going to put the x out in front so that it doesn't get all mixed in with the ln. Okay. Okay, so that cancels out these guys. And then what I'm going to do is I'm going to add ln 3 on the other side, on both sides, so that I get only the x terms together. Okay. All right, so on the left-hand side, I'll be left with x times 2 ln 3 minus x times ln 2. And over here on the right-hand side, I'll have ln 2 plus ln 3. Okay, so all my x's are on one side, all of my non-x's are on the other side. So then here, at this point, since both of these terms over here, both of these terms have x in common, I'm going to factor that out because these are not like terms, so I can't combine them. So I can factor out the x, and this is probably as complicated as the exponential equations get. So 2 ln 3 minus ln 2. Okay, now that I have that x there, it's multiplication, so I'm going to divide both sides by what's inside the parentheses, 2 ln 3 minus ln 2. Okay. They cancel out. But that was the key step right there, factoring out the x once you get to here. Once you have them all on the same side, you can factor out the x. That's the key step. And then punching that into your calculator, again, keep everything in parentheses, keep the numerator in parentheses, and also keep your denominator in parentheses when you're punching this into your calculator. And you should get approximately 1.191. Okay, so again, so it only gets complicated when you have variables on both sides. Okay, when you have the x's on both sides, then you're going to have to try to get them together on one side and then factor out that x. Okay. Another type of exponential equation that we're going to be solving are the ones that are quadratic in form. Okay, so, and this is where that substitution method that you learned back in quadratics comes into play. All right, so let's go ahead and solve this. 3 to the 2x minus 2 times 3 to the x equals 8. Okay, so just like regular quadratics, we want to set it equal to 0. So we can use the 0 property once we have the factors. Okay, so let's set this equal to 0. So subtract 8 on both sides. Okay, so if you notice here, we have 3 to the 2x, and then over here we have 3 to the x. Okay, so that 3 to the 2x is just 3 to the x squared. Okay, so one way to look at this, if you want to use actual substitution, you can see that u could be 3 to the x. So u squared is 3 to the 2x. Okay. Waiting for this. There it is. Okay. So if it's easier for you to do that, that's fine. And then back substitute, you can do that. Okay, so if you want to rewrite this as u squared minus 2u minus 8 equals 0, that's fine. It kind of keeps it a little clean and a little less distracting with all of the symbols there. And then you can factor as usual. Okay, u times u, positive, negative, and it looks like it's going to be 4 and 2. Okay, so negative 4 and positive 2. So with this, we get u equals -2 and u equals to 4. Okay, and then so now we solve for u, so we need to back substitute because we need to actually solve for x. So let's take a look. What is u? U is 3 to the x, so let's replace that u with 3 to the x instead, and we'll solve for x. Okay, so it's 3 to the x equals -2, and 3 to the x equals 4. And now these are the simpler type of exponentials. Okay, so we can take the log. Okay, well, it's still recording. I don't know what happened there. Okay, so a little bit of technical difficulty there. Excuse my language. All right, let's see if we could. This doesn't sound like it's working. Okay. Okay, there it goes. All right, I'm going to hurry up and wrap this up uh, because this is the last one for exponentials, and then we start logs, but I'll start a new video for that. Okay, so here solving for x, take the log of both sides. Okay, so here we can't take logs of negative numbers, so this one produces no solution on this side. Okay, and this one over here, if I take the okay, so here it is. So ln, let me see if it'll work. Ln of 3 to the x equals ln 4. Divide both sides. Bring down the x. Ln 3 equals ln 4. Divide both sides by ln 3. And you should get that x is approximately equal to 1.262. That whole video. Okay, so 1.262. And that pretty much ends it for solving exponentials. Look for the next video, which deals with solving logs.